4, using logarithms. Our objective today is to use logarithms in the exponential equation. Just wanted to say a quick shout out to all of you who have been watching the videos, and thank you for joining us on this distance learning journey. So we'll get started here with the warm-up. So first, vocabulary in the expression 4 to the 5th power, the base is 4 and the blank is 5. That little number up there is called your exponent. So that tells us the repeated multiplication of that 4 is going to be multiplied out 5 times. Part 2, what is the value of 2 to the 3rd power? Well, 2 to the 3rd power would be taking 2 times another 2 times another 2. 2 times 2 is 4 times another 2 is 8. Now here's what we're going to be looking at today. We are going to be finding missing exponents using what are called logarithms. So number 3, what value of x makes the equation 10 to the x equal 100? So you're asking yourself, what power do I need to take 10 to make it 100? Well, that would be 10 times 10, so x would have to equal 2. And we're going to use a math operation called logarithms in order to find those missing exponents. So there you have it. There's our warm-up. We need to know what exponents are, and we need to know how to evaluate exponents using that repeated multiplication. Applied to a specific base to obtain a given value. So a logarithm is basically the exponent that you need to make an exponential equation true. So first we'll look at the exponential version of an equation and then use that to convert into a logarithm version. So first, an exponential equation is y equals some base to an exponent. We'll call it x. So y equals b to the x power. In logarithm form, logarithms solve for exponents. So in logarithm form, this would be considered x equals log, and we actually write out the word log, base b, so the base of our exponent b becomes the base of our log, and that's called a subscript. So I'm writing that a little smaller and a little lower than my text for log. And then my answer, y, is going to go in that position. In the y, my text for this y is going to be the exact same as my text for my log. So the only difference is the little b is a subscript. It's going to go below and a little bit smaller. So the example from the warm-up that we just did, we asked, what do you need to raise 10 to get to 100? So that would have been the exponential equation 100 equals 10 to the 2nd power. Well, in log form, that would look like this. Our exponent is what logs are solving for, so that goes in this position. 2 is equal to our log. After we write our log, we're going to put the base of our power, which was 10. So I'm writing that 10 a little bit smaller, a little bit lower. And then my answer to the problem, the exponential, was 100. So this is telling me that 2 is the exponent needed to take the base of 10 and get an answer of 100. So that is how we can start to solve for exponents when we have an x or any type of variable up in the exponent position, rewriting it in log form. So from above, just kind of scroll up, use these models to help us to write these in log form. So we see the one that we did, we have 100 equals 10 squared. All right, so here we have 3 to the 5th power equals 243. I'm going to start by writing out my exponent. So my exponent is going to equal the log. So logarithms are solving for exponents. So 5 equals log. My base of my exponential form is a 3. I'm using this 3 right here. And that equals 243. So I got 5 is equal to log base 3, 243, which tells me that when you take 3 to this 5th power, you're going to get 243. Secondly, we've got 4 to the negative 2 power equals 625 10,000ths, or 0.0625. So we'll have our exponent negative 2. equals our log. Base of this exponent was 4. Answer to the exponent problem is 0.0625. And there it is in log form. So our logs, again, are always going to equal whatever that exponent is. So write each logarithmic equation back to exponential form. And what I like to do is I just like to write both the exponential form and the log form. So just really quickly, remember your y equals b to the x. It converts to x equals log. B is a little subscript, and then y is the same text as your log. So we have, right now, we're in this log form over here. We want to convert it back to exponential form. So one thing to really identify right away is whatever it's set equal to, that's your exponent. This little subscript is your base. So in this case, we're going to have 7 to the third power is equal to 343. And you could check that that is true, but that is a true logarithm, which also makes it then a true exponential. Secondly, we identify our exponent first. It's equal to 2. There's your base, 9. So we're going to have 9 to the second power is equal to 81. That's a little bit easier. That's one we do when we're doing square roots, things like that. So that is a true statement as well. 9 to the second is equal to 81. So there we have converting from logs to exponential form. Maybe you've already heard the word logarithm. Logarithmic scale is used when you're measuring things in the same base powers, and a lot of things in science are measured in base 10. Like you have your kilometers are 1,000 meters, millimeters are 1/1000th of a meter, and so everything is based on powers of 10. But a common logarithm is a logarithm that has a base 10. So if there is no base written for a logarithm, if you see something like this, just y equals log x, you assume that this base right here is going to be a 10. So if we were going to convert that to exponential form, that would be x equals 10 to the y. So you're assuming that that base, even though there's nothing there, that is going to be a power of 10. Each of a liquid to test whether it's acidic or if it's basic. So if the hydrogen concentration is 0.000000040 meters per liter, moles, per liter, is the liquid an acid or a base? So just a reminder, a base has a pH level above 7 and an acid has a pH below 7. Well, scientists use this formula to help them find the pH scale of certain liquids. So the pH is equal to the negative log of that hydrogen concentration. And hydrogen concentration is expressed with H+. So whatever your hydrogen concentration is, you can put that into the formula, negative log, and you can start to calculate the pH. So we're going to take a look at our calculator. We're going to find that log button, and then we're going to calculate the pH level of this liquid with this certain hydrogen concentration. Calculator, and then using that pH formula. So the pH formula is negative and then log, and our log button is going to be right next to the 7. So our log button that's accessible on our calculator is the base of 10. You can also see the exponential form of that, 10 to the x, is also on that key. So if you hit second, you can get raised a power of 10. But we're going to hit log, and then we're going to put in our hydrogen concentration. So it ended up being 0.70. So 1, 2, 3, 4, 5, 6, 7, and then a 40. And then we'll calculate its pH. So negative log of that value, we hit enter, and we get 7.39, so about 7.4. Or an acid, so pH level above 7 is a base. So in this particular case, our liquid would be a base. And that concludes our lesson 64 and then also our Algebra 2A class for the whole year. So just want to again say thank you to all who joined. We miss you, and on behalf of Miss Garrett's, Mr. Hanson, and me, we miss you guys, and hope you have a great summer, a safe summer, and hope to definitely see you back in the fall. So again, we're all very proud of you and wish it didn't have to come to this, but you've all been very resilient and did a great job with distant learning. So this is Mr. Engel signing off for the last time. Have a great summer. We'll see you later.